Okay, product property says that if you multiply if you multiply radicals with the same index, you can just multiply what's inside. Okay, so here's a couple things to think about. One, you can go ahead and multiply what's inside, and then you can simplify it, or you can simplify it and take everything out and multiply what's left over. I do it the second way. So if I were to multiply 6 and 8, I know that's an easy one that just gives you 48. But then I'm going to factor it to try to figure out what comes out and what goes back in. That's not a big deal when it's 48, but when you have huge numbers and then you're trying to factor, it's a pain, all right? And so I always factor up front and get all those together, except for my variables. We're going to do our variables a little bit different. So if I have something like this, I'm actually going to go ahead and break it up into primes. 2 and 3, 2 and 4, 2 and 2. Like, I don't even bother multiplying, because then when I get 48, I would say 2 times 24, 212, 2, like I'd go all the way down anyway. So then I'm just going to say, well, it was an index of 2. So among all of those, I can now take out pairs. So I can take out a 2 here. I can take out another 2 here. And I will have a 3 that is left inside. And so here I'm going to get 4 square root of 3 as my answer. That's the same answer I would get if I said 48 and then did my factor tree for 48. Okay? But I always do it this way so that I don't have sometimes you'll get this huge number to then factor once you've multiplied what's inside. And you can just get all the factors together. For this one, I already have a 2 and a 5 on the outside. So I'm going to go ahead and write those down so I don't forget them. Okay? This is cubed root. So don't automatically think, oh, well, 4 has a square root. We're not talking about square roots. We're talking about cubed roots here, okay? So a couple ways to think of this. You can factor that. This one in particular works out nicely because this automatically has 3 4s there. If it didn't, I would do the same thing here that I did over there. I would use my factor tree and take out anything that has groups of 3. So here I know that a 4 is going to come out because I have a 4 from this 4 and I have 2 4s from the 16. You can break it all the way down to 2s, but you're going to have 2 sets of 2s that come out. So what I can pull out here is a 4. Let's look at my variables. With my variables, I typically go ahead and multiply them. X squared times x, that gives me x cubed. And then I'm going to use my little method here. Divided by 3, that's 1, remainder of 0. So that means 1x comes out, no x's stay in. I have an x that came out there. And then I can just multiply. 2 times 5 times 4 is 40x, and actually nothing stayed in there. Nothing stayed in there. So when you do something like this, take the I out first and pull it out here. And then you can use your factor. Anything that groups according to your index can come out. Anything that doesn't group according to your index stays in. But I squared is going to be replaced with a negative 1. So that's where we get this negative 3 from. So when I am distributing, I have one number on the outside. I am going to just multiply through. I just multiplied through to each one. Make sure you're multiplying your outside and your outside. Here I multiplied the 2 and the 1, and the 3 didn't have anything. Here I multiplied the 3 and the 2, and the 6 and the 3. The 6 and the 2, and the 3 and the 3. So the outsides multiply, the insides multiply. And then I just simplify it. What can come out, comes out. And then if anything is alike, I can combine it. If not, I'm done. Foiling is exactly the same. Multiply the outsides, multiply the insides. If you have like terms, combine them. If you can simplify your radical, simplify your radical. All right, but you're just doing it one step at a time. Let's look at this one with imaginaries. And we have actually foiled imaginaries before, so this should be a little bit easier. 1 times 2, 1 times negative 5i. 3i times 2. 3i times negative 5i. Just like we did with radicals, if they're alike, combine them. Here's the thing. This is negative 15 times negative 1, so this is a positive 15. So now I can combine 2 and positive 15, negative 5i, and positive 6i. So we are just mixing and matching like terms, whether it's like radicals or like imaginary numbers. All right, try a couple. Distribute the first, foil the last two. These don't have the same index, right? But I can rewrite them in exponential form. This is 3 to the 1/2. This is 9 to the 1/3. I can write this as a 3. 3 to the 1/2 times 3 squared to the 1/3. I can combine those because a power to a power you multiply. And then you can add your exponents. So if you can get it to the same base, you can simplify them into 1.